Mechanics. So A-level maths is split up into pure maths and applied. And then applied is split even further into statistics and mechanics. Okay. So what is mechanics, first of all? It is the branch of applied mathematics dealing with motion and forces produced in motion. It is the point where maths and physics cross. You'll see a lot of stuff in mechanics that you'll also see if you did physics A-level or maybe from GCSE physics as well. It involves a lot of mathematical modeling, so modeling key ideas and different events. Working with forces and motion, and generally, the things that we need to know beforehand is being able to change freely between standard units and compound units, being able to plot and interpret graphs to solve simple kinematic problems. We will be using some integration, so looking at area under the curve with velocity time graphs. That's something that we'll do in pure maths that will support our mechanics, and then having a look at vectors later on in this video as well. So overall, we're going to learn to understand SI units, convert between them and other metric units, calculate average speed and average velocity, draw and interpret graphs of displacement and velocity against time, derive and use formulae for motion, and use calculus to solve problems involving variable acceleration. And as I mentioned, calculus will come up in pure maths. So topics within sort of forces of motion is we've got our speed and velocity, acceleration, forces, both balanced and unbalanced, our Newton's laws of motion, and looking at mass, weight, and gravity, and how they all impact motion. So you may recognize some of these equations already. So we've got like average speed is change in distance divided by time, velocity, same idea, and acceleration, velocity divided by time. And then at the bottom, F equals ma, force equals mass times acceleration. And these will be used throughout. And as you can see on the right-hand side, they're also seen in different forms as well. Now, in this video, looking at sort of the start of mechanics, we're going to be looking at the difference between vector and scalar quantities, and may even have a look at drawing some basic force diagrams as well. To start with though, let's have a look at fundamental quantities. So fundamental quantities are all of the things that we can measure. So for example, length, you might use a meter ruler to measure how long a table is, for example. You might be looking at mass to see how heavy something's going to be. Time, we measure time in minutes, hours, seconds, all the time throughout the day. We're always measuring time. Now, other fundamental quantities that we've got that we won't be looking at in A-level maths is electric current, temperature, amount of substance, and luminous intensity. Thinking about those quantities in regards to their units, we have the SI units, which you should probably have covered in GCSE physics. So standard units that we use for everything. So for length, we're talking about meters. In mass, we're talking about kilograms. Time, we're talking about minutes, hours, seconds. Okay, so these are our units and the quantities that go with them. Okay, looking at one of these, we've got distance here. We are going from A to B, and imagine this blue line as the road that we're taking. The distance is the length along that line. But if we just went as the crow flies, so straight from A to B in a straight line, that would be displacement. Okay, so displacement is actually how far it is from A to B, and distance is sort of along the road, the actual distance that we travel. And the difference between these two is one is scalar and one is vector. Scalar quantities just have magnitude, so just have size, and vector quantities have magnitude and direction. And you may recognize this little gif about being vector, committing crime in both direction and magnitude. So have a think for a second. Out of all of these different quantities here, which ones are scalar and which ones do you think are vector? So remember, scalar just has magnitude, so size, and vector has magnitude and direction. Okay, so the vectors are displacement, velocity, acceleration, force, momentum, and weight. And the scalar ones are distance, speed, time, energy, power, and volume. Have a think for a second. Just make sure you're happy as to why each of those are the one they are. Okay, so what I'd like you to do now is pause the video, and I would like you to have a go at matching up the quantities on the left with the definitions on the right. If you need to, go back to a minute ago when we said which of these quantities were vectors and which one was scalar quantities, and that should help you figure these out. When you're ready for the answers, press play again. Okay, and these are the solutions. So force is an influence tending to cause the motion of a body. Velocity is the rate of change of displacement. Speed is the rate of change of distance. Acceleration is the rate of change of velocity. Weight is the downward force on an object due to gravity. And displacement is the change in position of an object. Okay. Make sure that you've got these definitions in your orange book. They will be really important.